Hi everyone, today we're going to explore another PSLE question on volume. Now, in my opinion, this PSLE question is even more interesting than the volume question that the Education Minister shared in Parliament a few months back. Now, if you have not seen that question, you can click on the link here to access the video. And for those of you who have not seen this question before, you might want to pause this video now and try solving this question before watching. I'll wait for you here. All right, let's continue. There are two parts in this question. Part A is only 1 mark and it's pretty easy. Part B is 3 marks. And part B is the one that most students may struggle in or may take a long time to solve the question. So for students who are not trained, they will most likely use guess and check to try and solve the question. And not to say that there's anything wrong with that, just that it may take quite a bit of time, and we know that time is important during exams. So long story cut short, part B is about Sam pouring some water from container X to container Y without spilling. After that, the height of the water level in both containers will be the same. How much water did Sam pour into Y? To answer that, we have to first of all find out the height of the water in both the containers after Sam poured the water from X into Y. This is when students might use guess and check to find the height of the water level in the end. So I'm going to put myself in their shoes and try using guess and check to find that height. So I'm going to draw a table to help me with that. So here's the table. So the first column will be the height of the water in both the containers after the transfer was done. The second column, where I label X, is the volume of water that's inside container X. And the third column will be the volume of water in Y based on the height of the water level that we guess. And the fourth column, X plus Y, will be the total volume of water in both containers. And that volume of water in X and Y should add up to 780 cubic centimeters. So from there, we will decide if the height that we guess is correct or not. Now, before we make our first guess, students have to understand that in order to find the volume of water in the container, we have to take the base area of the container multiplied by the water level, the height of the water in that container. So we need the base area of the containers first. For container X is given is 30 square cm. For container Y, we need to work it out first. So we can take length times breadth, 30 times 9. That will give us 270 square centimeters for its base area for container Y. So now we are ready to guess the height of the water level in both containers. Now I'm going to start off by guessing that the height of the water in both containers is 10 centimeters. So if the height of the water level in X is going to be 10 cm after Sam had poured away some water, and knowing the base area is 30 square centimeters, so if I take 30 times the height of 10, I'll get 300 cubic cm of water in X. As for container Y, the base area is 270, and if the height of the water level is 10, then the volume of water in container Y will be 2,700 cubic cm. And the total volume of water in both X and Y will be 300 plus 2,700. That will give us 3,000 cubic cm. And that's incorrect because the total amount of water in both X and Y should be 780 cubic cm. So the first guess of height 10 cm is incorrect. So for students who are able to identify that 3,000 cubic cm is more than 780 cubic cm, the second guess for the height of the water would have to be less than 10 centimeters. So let's go for a height of 7 cm. So let me work it out quickly. The volume of water in X will be 210 cubic cm, and the volume of water in Y should be 270 multiplied with 7. You will get 1,890. And that's a combined volume of 2,100 cubic cm. Again, it's too much. So this 7 cm is a wrong estimate also. So let's try 5 cm. And the volume of water in X will be 30 times 5. That will be 150 cubic cm. As for the volume of water in Y, it will be 270 times 5. You will get 1,350 cubic cm. And the combined volume is 1,500 cubic centimeters, and again is a wrong guess. But we are getting closer because the total combined volume should be 780. So let me just decrease the height to say 2 cm. So if the height is 2 centimeters, then the volume of water in X will be 30 times 2. That will give me 60. And the volume of water in Y will be 270 times 2. That will give me 540. And together, they will add up to 600. So that's lesser than the 780. So now we know that we need to have a higher height instead. So this is wrong. So let me go up to 3 cm so that we can increase the volume a bit more. So if the height of the water level is 3 cm, then if we take 30 times 3, we will get 90 cubic cm for the water in X. As for Y, if we take 270 times 3, we will get this volume of 810. And now if you add them together, you get 900. That's a little too much. Now, if the height of the water level in both containers are 2 cm, then the total combined volume is only 600. But if it's 3 cm, then the total volume is 900. So that means that the height of the water in both containers should be between 2 cm and 3 cm. So it could be 2.1, 2.2, 2.3, or maybe even 2.35. So what is the next guess that I should actually make? And we can see that it's actually quite tedious and time consuming to use guess and check to figure out what the height of the water is, especially during exams when we have limited amount of time. As it stands, we are still not quite done yet. We still have to try a few more guesses before we can derive the answer. And this can be frustrating, especially during exams when students are nervous or rushing for time. So is there a shorter way to find the height of the water in both these containers? Apparently, yes. For students who are trained in this type of question, they could find this answer in 1 or 2 steps. But before using that method, we have to understand a few things first. Let me explain. Now, if you look at this table, the first thing you must take note of is that even though the height of the water level in both the containers will be the same in the end, the volume of water in both the containers are going to be different. Why? Because these two containers have different base areas. In other words, the bigger the base area of a container, the more the volume of water in that container if the height is the same. Now it's like that. Imagine you fill up 2 cm of water in your water bottle versus a swimming pool that has water filled up to a height of 2 centimeters. There will be a lot more water than the water bottle because the swimming pool has a larger base area. So that's the first thing to take note of. Number 2, the original volume of water in X was 780 cubic centimeters. Now, after some water was poured from X into Y without spilling, the total amount of water in both X and Y should also add up to 780 cubic centimeters. And the reason is because water has a definite volume. So if we don't take account into evaporation and stuff like that, after transferring some water from X to Y, one thing remains unchanged, and that's the volume of water. It's always going to be 780 cubic centimeters. And now I want you to imagine this. I'm going to put the two containers side by side, and somehow I'm going to magically connect a tube from X to Y somewhere near the bottom of both containers to allow the water to flow from X to Y. And the water will flow from X to Y until both the height of the water in the two containers are of the same height due to gravity. Now, if you can't visualize that, you cannot imagine that, it's okay. This is how it will look like. Now, the water will stop flowing from X to Y when the height of the water in both the containers are the same. At this juncture, the total volume of water in these two containers will still add up to 780 cubic centimeters. But this 780 cubic centimeters of water is no longer just resting on the base area of container X. It is now resting on both the base areas of container X and container Y. And we can find the height of this water level by simply taking the total volume of water in both containers, the 780 cubic cm, and divide that by the combined base area of X and Y. Because now this 780 cubic cm of water is resting on both the base area of X and Y. So if you take 780, the total volume of water in both containers, divide that by the combined base area of X and Y, that will give you the height of the water level. So with this understanding, I'm going to show you a step-by-step explanation to solve this PSLE volume question.
X and Y are two rectangular containers. The base area of X is 30 square centimeters. I'm going to use a blue highlighter to shade the base area of X. So this area in blue is 30 square centimeters. And the base of Y has dimension as shown. So I'm going to use the same blue highlighter to shade the base area of Y as well. So we can find the base area of Y easily by taking the length multiplied by its breadth, 30 times 9, and that will give us 270. So this area here in blue is 270 square centimeters. X contains 780 cubic centimeters of water. So over here, the volume of water is 780 cubic centimeters and Y was empty. Part A. What was the height of the water level in X? To find the height of the water in X, what we can do is just simply take the volume of water in container X, divide by its base area, which is 30, and you will get the answer 26 centimeters. That is the height of the water level in container X. Part B. Sam poured some water from X into Y without spilling. So some water is apparently poured from container X to container Y without spilling. After that, the height of the water level of X was the same as that of Y. So obviously the water level in X will go down and the water level in Y will rise when water is transferred from X to Y. And it will continue until the height of both water levels in the containers are the same. Now this straight line that I'm drawing indicates the height of the water level in both containers in the end. So they should be the same. So the height of the water in Y increases, the height of the water level in X decreases, and I'm going to shade away the volume of water that was transferred away. Now take note that even though the height of the water level in both the containers are the same, the amount of water, the volume of water may not necessarily be the same. And in this case, they are not the same. The volume of water are not the same because container Y has a larger base area. So to find the height of the water level in both containers, making use of the concept that water has a definite volume. Alright, at first the volume of water was 780 cubic centimeters only in container X, and now some of the water is transferred to container Y. The total amount of water, the total volume of water in both X and Y will still be 780 cubic centimeters because water has a definite volume. So now this 780 cubic centimeters of water is resting on both the base area of X and Y. So to find out the height, we can just simply take 780 divided by the combined base area. So that will be 30 plus 270. And if you were to use a calculator to work it out, you will get 2.6 centimeters. So the height of the water level in both containers is 2.6 centimeters. The question is, how much water did Sam pour into Y? So with the height found, we can actually find the volume of the water in container Y by simply taking the base area 270 multiplied by the height of the water 2.6, and you should get 702 cubic centimeters as your answer.
In future, if there's going to be a similar question whereby the height of the water level is going to be the same in all the containers, I hope you will be able to use this method instead of guess and check to solve this type of question quickly. But having said that, there will always be tweaks to the questions that they ask students during exams. For example, there's another question that came out in PSLE whereby some water was poured from container P to container Q, but this time round, the height of the water level in P was twice that of the water level in Q. Instead of being the same height, the water level in P is 2 times higher than the water level in Q. Would you be able to make use of what you have just learned and apply it to solve this question? Let me know your answer in the comments below. I'll see you at the next video.